To solve these three equations with three unknowns, we're going to primarily use the addition method. So solving using addition. So we're basically going to do the same thing as before. So I'm going to say do the same thing as with two equations and two unknowns, except, I'm going to say kind of. What we're going to do is we're going to eliminate the same variables from two different pairs. So essentially what we're going to do, so eliminate the same variable from two different pairs of equations. And then we're going to have two equations and two unknowns, which will be something we already know how to solve. So then solve this remaining system, or the new system I'll call it. Solve the new system of two equations, two unknowns. And then once you have that, solve for the last, or for the remaining variable. And it's going to sound super complicated, but it's really not. It's not easy, but it's not overly awful. The instructions make it sound worse than it actually is. So really the best thing to do is just to go straight into this and start working on an example. So say we've got something like this. 5x minus 2y minus 4z equals 3. And then 3x plus 3y plus 2z equals negative 3. And then minus 2x plus 5y plus 3z equals 3. Okay. So our goal is going to be just to eliminate one of the variables so that we're left with a system that has only two equations and two unknowns. So I'm going to label my equations 1, 2, and 3. And I'm just going to arbitrarily pick a variable. It doesn't really matter which one you pick, just pick one and stick with it. So I'm going to choose to eliminate, what should I do? Choose to eliminate, I'm just going to go with z, because I don't like z. We're used to x's and y's, so let's just go ahead and get rid of z. So I'm going to choose to eliminate z. So I can pick the first and the second one. I can go with 1 and 2, or I can go with 2 and 3, or I can go with 1 and 3. And basically I'm going to pick the equations that I think will be the easiest for me to eliminate z from. Now unfortunately they're all kind of tough. So I'm going to again arbitrarily choose to use 1 and 2 to get started. Okay, so I've got 5x minus 2y minus 4z equals 3, and then 3x plus 3y plus 2z equals minus 3. And again, my goal is to eliminate z. So let's see what I need to do. I can leave the top one as it is, just fine and dandy the way he is. But if I want to be able to add them and get rid of the z, I need to multiply that 2 by something to make it be 4, right? The minus 4 needs to interact and go away. So that 2 needs to be a 4, right? Now if I make the 2 into a 4, I can do that by multiplying both sides by 2. And that gives me 6x plus 6y plus 4z equals minus 6. Now if I add that straight down, just like we've been doing on the two variables, two equations, two unknowns, get 11x plus 4y plus 0, which is a good thing, equals negative 3. So now I have a new equation like this. Okay, I have a new equation like this, which is all fabulous and well and good and stuff like that. Okay, so now I need to get rid of z again using a different pair. So you see what's going to happen? I'm going to get another equation that just has x and y in it, and then I know how to solve those problems. So I'm going to arbitrarily choose 2 and 3 this time. So now I'm going to choose to use 2 and 3. Okay, so I've got 3x. I'm going to move over a little bit, or I'm going to run out of room. I have 3x plus 3y plus 2z equals negative 3, and minus 2x plus 5y plus 3z equals 3. And I want to get rid of z still. I'm still wanting to get rid of z, but in order to do it now, I'm going to have to multiply both equations. So I've got this 2 here, and I've got a 3 here. So I have to multiply I have to multiply one of them by a negative, so might as well do the first one by a negative. I can say, well, I've got a 2 and a 3, so I can multiply this one by negative 3. That'll make that a negative 6. Then if I multiply that by 2, that'll give me a positive 6. And those would be able to counteract each other. And hopefully would cancel each other out on the next step. The good news is if I do it wrong, they just won't cancel out. And I'll get a different answer. It won't cancel out and I'll know I did something wrong. So let's go ahead and multiply that through. Negative 9x minus 9y minus 6z equals 9. Minus 4x minus 10y plus 6z equals 6. And I'm going to add this straight down. This is how I did it last time. Add this straight down. And I've got negative 13x minus 19y plus 0, good, equals 15. So now I've got 2 fabulous equations. Minus 13x minus 19y equals 15. Let me make sure I did that right, because I'm always paranoid that I'm going to do something silly. I did do something silly. Okay, I did do something silly. 2 times positive 5 is positive 10. So in case you were wondering why I did that, it's because I was wrong. That's how. Okay, how about that? That looks a little bit better. Let me make sure I did everything else right. Okay, that looks more convincing. All right, so I've got 13x minus y, or plus y. I'll get it there. Minus 13x plus y equals 15. Okay, so that's what we've just done. We did this part. We just did that. Now we're going to be on this part. Now we have a new system with 2 equations, 2 unknowns, and we can solve for x and y. So this is like step 2, if you're keeping track of steps. I guess I could label my steps. This would be step 1. So 1, 2, and 3. All right. So step 2 is I'm going to pretend none of that ever happened, and I'm just going to pretend that I was strolling through the park and I found this set of 2 equations and 2 unknowns to solve. And sometimes it even helps just to leave your homework and come back, because you just might be kind of blah from doing that. If you're a little overwhelmed, that's fine. Just, it's all good. We'll make it through. Okay. So now I can solve by addition again. I can say, well, if I multiply this one, I'm going to move them over a little bit. I could say, well, if I multiply the second one times negative 4, right? If I multiply the second one times negative 4, that should do me some favors. So 11x plus 4y minus 3. And then 13 times 4 is 52. 52x minus 4y. And then that's minus 60. Add them straight down. Please let these not be ugly numbers, because I don't like ugly numbers in my work. Plus 0, so that's good, equals minus 63. Look at that. Holy jamalama. Look, look, look. Oh my gosh, isn't this why you're just ridiculously excited now? Because you get this, and you can say, oh, look, 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 I divide both sides by 63, and I get x equals -1. Oh, man, that's so wonderful, because you don't want to get x equals 17 over 2, or 366 over 47, and something like that, because then it's just awful. But when you get an integer like that, that means you've got a pretty good idea that you did that right. And if you get something right, then it means you don't have to do the problem again later. So it's just absolutely wonderful. Okay, enough for that celebration, which is probably over-enthusiastic, but hey, it's a math class. You need to be overly enthusiastic. So I'm going to use this equation now and plug in my x equals -1 to solve for y. So I've got -13 times x plus y equals 15. 13 plus y equals 15. And then subtracting 13 from both sides, y equals 2. I'm going to write it down here. Y equals 2. Look it, look it, look it. Isn't it awesome? Y equals 2. Alrighty, so that's the end of step 2. Solve the equations, 2 equations, 2 unknowns. Now I'm going to solve for remaining variables. So I can pick any one of these original equations, and somehow I managed not to collect my y. I can pick any of these here. There we go. And I have x and y, so all I have to do now is solve for z. Copy. So this is now step 3. Step 3 is given this, and if I know x equals -1, y equals 2, and I can plug these in straight up. So I've got 5 times -1 minus 2 times 2 minus 4, oh, times z, because I don't know that, and then that equals 3. So -5 minus 4 minus 4z is 3, minus 9 minus 4z is 3, and I can add 9 to both sides, and then I can divide both sides by -4, and I get z equals -3. Look, I have an answer, and this is my actual answer forever and ever and ever. X equals -1, y equals 2, and z equals -3. You might have to, on your homework, turn it in as an ordered triple, but hey, I mean, you cannot ask for anything better than to have just wonderful, happy little equations that come out to nice, pretty integers and make the world a better place.